Of the semester. Last one. Awesome. You're right there. So the distributions we're going to look at are going to be geometric distribution and the plus sum distribution. And here's what geometric distribution looks like. It's a lot like binomial distribution, right? Trials are independent, probability of success is constant. You also want each trial to be listed as either success or failure. The difference is you are looking for the first event that is a success, right? You're not saying, hey, what's the probability you have 5 successes or the probability you have 2 successes, right? Or up to 5. Now for geometric distribution, you're just finding the probability of the first success, okay? Happening on some trial, right? All right, so let's do an example. This is our only example. We're going to do this, and it's decent because it kind of encompasses everything you would want to do with a geometric distribution. So, LeBron. He makes a free throw shot about 74% of the time. We're going to look at the probability that LeBron makes his first free throw shot before his third attempt, right? And so he either makes it the first shot or the second shot, right? So, we are looking at the probability that X is sorry, wrong way, less than or equal to 3. Now, I'm not going to put the probability that X is 0, right? Because that would be weird, right? It doesn't make sense in this context that you would make a shot on the 0th time, right? It's weird, right? So, what that is going to be then is the probability that X is equal to 1 plus the probability that X is equal to 2. And we are going to use our calculators to do this, okay? So we were using the binomial PDF and binomial CDF up to this point, right? We are going to go ahead now and use geometric PDF, and I'll show you how to use the geometric CDF as well. So, we'll go to our handy-dandy calculator. We can do this using just the calculator. So you can hit the little calculator button. We are going to hit menu. We're going to go to the same place we were before, right? Probability, distributions. And now if we go, actually I'm going to go up. It's going to get quicker there, get me there quicker. I'm going to go to geometric PDF. I'll hit enter, and it's going to ask me, what's the probability of success? Probability of success, 0.74, right? X value, let's look. So this is going to be the probability that he makes it on the first shot, okay? And 0.74 makes sense, right? If he makes them 74% of the time, should be a 0.74 probability that he makes it on the first try. So this one. Now, what's the probability that he makes it on the second try? In other words, we're saying he shot one, he missed, right? Shoots the next one and makes it. What's the probability of that occurring? We're going to go to the same place, menu, probability, distribution. We go up to geometric PDF. And now probability of success is still the same, but the X value is 2. Probability he makes it on the second shot. It turns out to be 0.1 9 approximately, right? We'll go, I don't know, just 94 is what it was. Alright. And then if we add those up, which we can do, right? I can actually go up and say, hey, I'll select this one, enter, put a plus sign, go up, find the next one, enter. So it's a 93% chance. So if you were to interpret that in context, right? That means that LeBron, if he goes up, if he gets a free throw, there's a 93% chance that he's going to get at least one. That he'll make it on either the first or the second. Okay. Now there's another way to calculate this, okay? But I wanted to show you how to do the individual ones first, right? So if the question was just asking, hey, what's the probability that he's at the free throw line and he doesn't hit a shot until the fourth shot? You would go through what we did, right, and make x equal 4. It's probably pretty low. That probability is probably super, super low. But if you're going to add it up, you can do it this way, or we can go to menu, go back to probability, distributions, find geometric, but now we're going to go geometric CDF. And we're going to use this for a situation where it says at least, right? He makes it for, well, not at least, but before a certain attempt, right? Or not exactly. Probability of success is 0.74. My lower bound is 1 because it can't be 0, right? And then my upper bound is 2. Whoops. Upper bound 2. And we got the same thing as we got before, which is good. That is perfect. Huh? 1 and 2. And that's pretty much all you got to do for this geometric distribution. I think the trickiest thing with this, you need to do CDF. See this one is CDF. The trickiest thing with these is recognizing which one to use, right? So we've learned binomial, geometric. Now we're going to learn Poisson. And there's a good exercise in your homework that has you try to figure out which one. That's a good thing. After that, it's just using the calculator, right? So let's go ahead and look at the Poisson distribution. If we were going to use a formula, that's what we would have done. We're using our calculators. So here we go. Poisson. Poisson, like les poissons. What? Money what? Okay, so we're going to look for the number of times a certain event occurs. How many times does a car stop at a traffic light? Things like that. So you'd be given some sort of interval of time, area or volume, right? So the number of cars that stops at a stoplight within an hour. They'll say something like, on average, there will be 30 that stop at this stoplight an hour. And then you'll find the probability that there are 20 that stop, something like that. Will be an example of this problem. And these are the rules, right? You got to have the same probability for each interval, and they have to be independent. Okay, so we will do 2 examples using this distribution. This is the formula that we would use for that, but again, we're going to use our calculators. So here we go, we'll get right into it. The mean number of accidents per month at a certain intersection is 3. What is the probability that more than 4 accidents will occur in any given month at the intersection? And before I begin answering this question, because more than 4 is weird. There's no like lower bound or upper bound and stuff like that for some. Or upper bounds are weird. You can't make the upper bound infinity or anything like that. So what we'll do is we'll take the common. So the probability that there are more than 4 is the same thing as 1 minus the probability that there are less than. That's the approach that we're going to use. So, let's look at that. What is the probability that there are less than 4? My bad, strictly less than 4. Well, that's going to be the probability that there are 0 plus the probability that there is 1 plus the probability that there are 2 accidents plus the probability that there are 3 accidents. We are going to use our calculator to get all of these things. And the first thing that we need to talk about is what our calculator is going to want to put in there, okay? So your calculator is going to ask you for this. Because lambda is going to be the mean. What they're going to say is the average or something like that, right? So in this case, lambda is 3, right? On average, there are 3 accidents, okay? Almost there. So, we'll go to our handy dandy calculator. We'll hit menu. We'll go, again, probability, distributions, and then we'll go to Poisson PDF. Lambda is 3, and then our x value we'll put in 0. That's going to give us the probability that there were 0 accidents. So that is approximately 0.05. 0.05. We get the probability 1. We'll do this both to the same process, okay? So we'll go menu, probability, distributions, and then we will go to Poisson PDF. Poisson, yeah, I hope that's not making you hungry because it sounds too much like croissant. And we get approximately 0.15. And then I'll get the other 2 just by copying and pasting, right? Because I just keep changing that x value, right? And there goes 1, we'll change it to 2. Enter, I'll go ahead and just do the copying and pasting. Change it to 3. So those are both about 0.22. And there it is. We can add that all up. Let's see. 4, 9, 6, 4. Right? Okay, good. Okay, we can get the same thing by using the CDF as well. So let's do that real quick. I'm going to show you how to use that function. So I'll hit menu, probability, distribution, and we'll go up to Poisson CDF. And now our lambda is 3, our lower bound is 0, and our upper bound is 3. We hit OK, we get around 0.64, which is what we got, right? But we weren't being asked the probability that there are 4 or less, which is what, or sorry, less than 4, right? Probably there are less than 4. We wanted to know the probability that there are more than 4, right? But all these probabilities have to add to 1, or else it's not really a probability distribution, right? We already determined that. So, in order to find the opposite, the probability that this doesn't happen, we can subtract it from 1. So, the probability that x is greater than 4 is going to be 1 minus the probability that x is I don't know why I'm drawing my equal. Probably that x is less than 4, probably x is greater than 4. Sorry. It's going to be the probability that x is less than 4, which is going to be 0.366. One last one. Oh yeah. All right, I've got 2,000 brown trout were put into a small lake for the first time, so we know that there are exactly 2,000 in there. The lake has a volume of 20,000 cubic meters. We're not going to use a table. We're going to use our calculators. We are going to just find the probability that 3 brown trout are found in any given cubic meter of the lake. So the trickiest part of this is figuring out what lambda is. What is the mean number of, what's the average number of trout you'll find in 1 cubic meter, right? So in order to figure that out, we'll just have to figure out there are 2,000 brown trout for every 20,000 cubic meters of lake, right? Which means that in 1 cubic meter,
Thank you, Mr.
you're welcome, there are 0.1 trout. Right, if you divide that thing. So then what we're looking for is the probability that x is equal to 3. We can put this into our handy-dandy calculator. So we'll hit menu, probability, distribution, and then we'll go find Poisson PDF, right? Because we're not adding up a bunch of them, we're just doing one. Lambda is 0.1, and the x value is 3. Because we're looking for 3 trout. So approximately 0.0002. And that makes sense, right? I mean, it's a big old lake, right? What's the probability in a cubic meter, right? An area maybe about like this, that there are 3 trout sitting right in there. It's probably pretty low. Unless you got a school. You got lucky. Which I've never experienced. Apparently it's cool. Yeah. Alright, 0.0002.
How long is the ceiling per chapter? 20 feet, 20 feet, close to 20,000 feet.
Oh, really? That's weird. That's a really small lake.
27 meters by 2 meters.
There's a pond. Right. Alright, and that is it. Your homework. Oh, sorry, I forgot to tell you this. On page 201, in your book, there's a very good table that has all of these distributions that we talked about, what their rules are, the formulas that go on them, the values that you're looking for. So it's a really nice thing to refer to as you do your homework, all right? And for an open book test. So we did it. There's your homework assignment. You guys can get started on it right now. It's on your calendar. That's it. That's all the new information for the year, guys. I mean, yeah,